Hello everyone, my name is Tolu,
My name is Ishan.
and we're here to present our final project for ME100, or the Internet of Things. So our project is called Smart Bike Lock, which is a smart security system which notifies you of when your bike has been stolen. We decided to address and create a solution for bike theft because of how common it is as a whole and how present of an issue it is at UC Berkeley.
Bike stats.
Here we have bike stats. So like I said before, they're very common across the US. At UC Berkeley alone, we average about 160 bikes being stolen per year, and our highest peak was about 299. More than 50% of property crime reported across all UC campuses are about bike theft. And every year across college campuses, 1.5 million bikes are stolen, and total in the US, 2 million bikes are stolen.
Right. So where did the concept or the idea of this project come from? So it kind of came from the saw stop, actually. So as you can see, the sausage is supposed to replicate a finger, and there's a current running through the metal blade. And once that current is disrupted through the non-conductive sausage, the securities feature enables and it goes down. So that's kind of where we got the idea.
So project overview, we have a live current flowing through the wire, and this current is constantly being read and monitored. And then once it becomes lower than a certain number that we evaluated, then the alert is sent to your phone, and that replicates a wire being cut or like your lock being cut.
And the correlation to our class ME100, the current, power, and voltage will be monitored using the INA219 sensor, which you can see right here in the middle. We will be using MQTT as the main communications relay for once the bike has been stolen, and all the responses, all the data will be uploaded to MQTT. So going over the circuit, which we have right here. So as you can see, as you can see here, we have our ESP32. Here we have the INA219 sensor, which is monitoring the current, and we have a parallel circuit. One of these circuits is going to replicate the cut. So when I disconnect this, that's supposed to mimic a thief cutting the lock and disrupting the current so that the message can go to MQTT. And here is our code. Screen.
So here's a brief explanation of our code. So at the beginning, you have data being imported into the code, and we have Wi-Fi connection being checked just to make sure everything's working well, and it'll connect for the MQTT. After that, we set up the Adafruit connection and define any functions that we need within that connection. And then we have it actually connect to the Adafruit server. And then it notifies you of when your Wi-Fi has been checked and when Adafruit has been connected. After that, we start the configuration for the INA219, and that continues until right before our while true loop. And then this loop basically does what we want the circuit to do. So the current will continue to run until the value that we set. So we set a 7.5 milliamp value. So once the current drops below this, then you'll receive a message that says that your bike has been stolen.
And yeah, and then here is a video of our project in action. Am I still sharing?
Yeah.
Okay.
Oh, you're still not.
1 second. Go. Here is a video of us running the code in lab using MicroPython. So here's just a normal day, current's being monitored every second. Here I'm going to simulate someone stealing it. And then it's going to say your bike has been stolen because the current value has dropped below a threshold, and it's going to upload to MQTT. And yeah, that is it for our project.
Thank you.
Thank you.